What's up, you crazy cats? It's video 11, Law of Sines, word problems. Let's get this bread. The Leaning Tower of Pisa is inclined at an angle of 10 degrees from vertical. Well, where's my vertical line? My vertical line is right here. That's vertical. So if I'm inclined 10 degrees from vertical, we've got the Leaning Tower of Pisa right here. Call this Pisa. And that's being inclined at an angle of 10 degrees from the vertical. Remember, this is your vertical, and then it's becoming 10 degrees inclined from the vertical. So that's how we would label that. Okay, let's take a look at this ship problem here. The location of the lighthouse from the ship is 40 degrees west of south. Well, where's my south line? It's right here. Okay, this is my south line. And I'm saying that it is 40 degrees west of south. Remember, west is this direction. We are on the west coast. Okay, so this is going in the westerly direction, and we're talking about this being 40 degrees. Okay, so our lighthouse is located somewhere on this line. The lighthouse could certainly be here. It could be here, it could be here. I don't know, right? But we do know that this angle right here is 40 degrees. All right, let's take a look at this next one. A tree is inclined at an angle of 8 degrees from vertical. Well, let's go ahead and draw that vertical line. And then we have a tree coming out. And that's going to be right here. Here's our tree. Okay, I guess that actually looks like a hand. Let's try again. That's our tree. All right, so this is a tree. And it's at an angle of 8 degrees. Now, you might say, Ms. Sorensen, how do you know it falls to the right? We actually don't know that. You certainly could have gotten this problem right if you had your vertical here and then it went out 8 degrees here. That's totally fine too, or this would be your tree right here. That's fine. But in some problems, it will tell you that it's leaning towards a certain person or thing. Okay, either of these is fine. All right, the next one says the location of the island from the ship is 30 degrees east of south. Well, of south, right, that's what we really care about for our first line. So here's our south line. This is south. And then we're going east this time. Remember, east is to the right towards New York. So we've got east is going this direction. Okay, that's my east line, and it's saying that this is 30 degrees. Go ahead and pause this video, see if you can come up with these two, and then I'll come back at you. All right. The location of the Naval Academy from the ship is 30 degrees east of north. Okay, well, we have to draw the north line. So we've got something like this. We've got a north line coming up like that. That's my north line. And it's going to be east of the north. So here's my east of the north, right? East is that direction, and that would be 30 degrees. All right, over here we've got the location of the school from Wapato Point is 25 degrees south of east. Of east. Well, where's my east? That's east. And I'm going to be south of that. So south would be this direction, and that would be 25 degrees. All right, fantastic. Let's start example 1. All right. One Coast Guard station is located 105 miles due west of a second station. So we've got 2 stations. We'll call one here and one here. And one is due west. So for example, this is due west. There we go. The location of the ship from the east station is 35 degrees west of south. The location from the ship from the west station, 42 degrees east of south. How far is each station from the ship? All right, well, let's start putting in this information. Let's start with the fact the 2 stations are 105 miles apart. Let's go ahead and let's call this the west station, and let's call this the east station, and draw a line right between them, and we'll say that this is 105 miles. So now let's start with this one right here. Let's say that we're talking about the east station, so we're going to talk about this one first. It says that it's seeing a ship or it's getting a signal from a ship. And it's getting that 35 degrees west of south. Okay, 35 degrees west of south. Well, here's my of south right here. And it's going to be 35 degrees west. That's to the left. So that's 35 degrees right here. 35 degrees west of south. And it's getting some sort of ship right here. All right, next here we have that for the west station. Okay, we're talking about this station now. It's 42 degrees east of south. So again, we've got that south line, but this time we've got 42 degrees east of it, right? East is going to be in this direction. So we're going to be east of south, something like that. And this one is a slightly larger angle of 42 degrees. And the question is, how far is each station from the ship? Well, first of all, looking at this triangle here, I don't have any angles inside the triangle, but what I do know is that we have a 90-degree angle right here. So if I do 90 minus 42, what do I get? Oh, I get 48 degrees. I can go ahead and label that inside as 48 degrees. So this here is 48 degrees. And similarly here on the right side, if I'm looking for this angle, I do 90 minus 35. Just doing that quickly in my head, I get 55. All right, so doesn't hurt to find the other angle. Not sure if we'll need it yet. I bet we will because we've got that 105 that we need an angle across from it. So I'm going to add up 48 and 55, and I'm going to go ahead and subtract that from 180, and I get that this remaining angle is 77 degrees. All right, let's go ahead and let's redraw this triangle and really try to figure out what is it asking for. So here's my triangle. Delete this. We've got 105 here. We've got a 55. We've got a 48 and a 77. All right. And the question is saying, how far is each station from the ship? Well, here's the ship. This is the ship that has the distress signal. And so we're looking for what this is here and what this is here. So I'm going to go ahead and label my triangle with A, B, and C. And so really what I'm looking for is lowercase b and lowercase a, because I'm trying to figure out how far is the west ship, which is this B, how far is the west ship from the distress ship, which is right here. All right, so what are we going to start with here? Let's start with B first. So if I want to find B, I'm going to use this here, and then I'm going to use this here. All right, so that's going to give me sine of B over B. And I'm just going to plug right in, okay? I'm going to go sine of 55 over B equals, and now I'm going to do sine of C over C. So sine of C is sine of 77. And then this is going to be over my C, which is 105. I just got all of that from what I circled over here. All right, so now what we're going to do here is we're going to cross multiply. All right, this here is going to give me a B sine 77. And right here we have a 105 sine of 55. Last step here is going to be to divide by sine of 77. Sine of 77's cancel out, and I'm left with B equals, all I do is do this right here in my graphing calculator. And that gives me roughly 88.3 miles. And does that make sense? Sure, if this is 105 miles here, I think 88.3 miles seems reasonable. So I'm going to put that in a box, and we're going to have to write a sentence at the end here, but let's just first deal with finding A now. All right, going back to this triangle right here, we're looking for A now. So I'm going to circle A inside A, and I'm also still going to use this 105 and this 77. So here we're going to use C and A, so that's going to be sine C over C equals sine A over A. So let's just plug that in. So let's go sine of A over A, so that's sine of 48 over A equals sine of 77 over 105. All right, cross multiplying here. That's going to give me an A sine 77 equals a 105 sine 48. Okay, I got to get rid of that sine 77, so I'm going to divide by sine of 77. The sine of 77's cancel, and I'm left with A equals 105 105 sine of 48 divided by sine of 77. I basically just rewrote this right here. When you plug this into your calculator, just a friendly reminder to remember your parentheses and closing that there. And I get 80.1 miles. So I get A is equal to 80.1 miles. Let's go ahead and let's bring that back to the graph here, or not the graph, but the triangle. And our B is 88.3 miles, and then our A is 80.1 miles. And remember, this A originally was our west station, and then this B originally was our east station. So answering this, we're going to say that the west station is 88.3 miles from the ship, and the east station is 80.1 miles. And that's really what I'm looking for. I'm going to mark you off a little bit wrong if you just keep this and this is your answer. You actually do have to answer the question. All right, let's move ahead. Example 2 here. A flagpole has been moved by the wind. It is inclined at an angle of 15 degrees from vertical, and it is leaning towards Brianna. Brianna stands 30 feet from the base of the flagpole, and she can see the top of the flagpole with an angle of elevation of 20 degrees. Find how high the top of the flag is above ground level. All right, well, let's deal with the fact that we've got a flagpole that has been inclined at an angle of 15 degrees from vertical. So here's my vertical, here's my flagpole right there, and we're saying that it is 15 degrees. And also notice how it says that it's leaning towards Brianna. So I'm going to put Brianna right here. There she is, looking fly. She's got a little cat with her. She is. All right, and Brianna is standing 30 feet from the base of the flagpole. Well, here's the base of the flagpole. So Brianna is 30 feet away. Now, here's the flagpole right here, right there. And it says that she can see the top of the flagpole at an angle of elevation of 20 degrees. So I'm going to just drop this down right here. And this is kind of actually a backwards Z. I'll show you that just quickly. It's not super important. But we've got yeah, it is a backwards Z. So her angle of elevation would actually be right here, which I think you were going to mark that anyway. So angle of elevation, let's mark that in there, is going to be 20 degrees. Perfection. What is this question asking for? It's asking for you to find how high the top of the flagpole is above ground level. It's actually asking you for the height right here, because remember, this was our flagpole right there. It's not a right angle, I was just trying to make a flag there. So we're really looking for H, height, right here. Okay, well, we can certainly fill in more information here regarding the angles. We certainly know that we have a right angle here because the vertical, this is our vertical line right here. Oopsie, let me bring that back. So if this is vertical, and that's 15 degrees, 90 minus 15 gives me 75 degrees here. All right, now I want to find what the angle at the top of my triangle is. And you're probably saying, what triangle are you talking about? We have a bunch. Well, let's just talk about this blue triangle right here. Okay, and I'm looking for this angle right here. Well, I already know that I've got a 75 degree and a 20 degree. That gives me 95 degrees. So I know that this angle right here is going to be 85 degrees. I'm just subtracting that 95 degrees from 180. Okay, so how can I undo that? I don't know anymore. I'm trying my best here. Let me bring that back. All right. So what did we just learn? We just learned that this blue angle right here is 85 degrees, and we're talking about that whole angle. All right, so now I want to find H. And if you see H, we're totally missing a side length of the triangle. So let me get out a new color here. If you look at this triangle, well, I have an angle, that's sweet, but I don't have a side length. I only know that this whole thing is 30. What I really want is I want this side right here, which would help me then have one side an angle and I could find H. Okay, so what I need to do is solve for that question mark right there. And to do that, I am going to use law of sines in the big triangle. Probably saying, whoa, Miss Sorensen, you are struggling. And you are correct on a daily basis. All right, so let's go back to that blue triangle right here. So going back to this blue triangle, I want to find what this is. I'm going to make it X. Well, look at here. We've got law of sines. So I really have, in this blue triangle, I've got 85. That's a pretty 8, don't you think? 85. And then I've got 30. And then I've got a 75. And then I've got X. So let's label this. Okay, let's label this with, I don't know, A, B, C, a B here, an A here, and a C. And so you can see that we can do law of sines with this. Okay, this is going to be that right there. All right, let's get her done. So we've got sine B over B, so that's going to be sine of 75 over X equals sine A over A, so that's going to be sine of 85 over 30. All right, cross multiplying here, I get X sine 85 is going to be equal to 30 sine 75. All right, I'm going to go ahead and divide by sine of 85. These sine of 85s cancel. And I do this math right here in my calculator. And I get that that X value is 29.1. And you can stop and check that that's true. So this right here is 29.1. All right, we're in really good shape here. Now I want to go back to that red triangle that I drew over here. That was this one right here. We're trying to find H, remember the height of that flagpole above the ground. And so now what I have on that red triangle is I have the hypotenuse is a 29.1. I'm looking for H. I know this is a right angle. I can add that to this picture here. And I also have this 20 degrees right there. So let me mark that 20 degrees right here. And you could do law of sines with this one if you wanted to, using that 90-degree angle. But I'm just going to do simple trig. It's kind of from our first video. So this would be my opposite side. Across from my 90 is my hypotenuse. So I'm going to do sine of 20 equals opposite over hypotenuse is going to be H over 29.1. And all I have to do here is multiply by 29.1 on both sides. All right, and that's going to cancel over here, and I'm left with my height is equal to 29.1 times sine of 20. Picking up my calculator, I do that, and I get roughly 9.95 feet. All right. All right. Last problem here. I'm going to see if I can run through this a lot faster than the last one because I was kind of explaining it for the first time, but let's just run through this one faster. So we've got a tree inclined from the vertical. It's leaning towards Sam the man, and it's 10 degrees. So this is going to be 10 degrees. And Sam stands 80 feet from that tree. And he can see the tree at 30 degrees. So we've got a 30 degree here. And we want to know how high the top of the tree is above ground level. We want this h. I'm going to leave that out for now just for ease of looking at this triangle. So if this is 10 degrees, we obviously have an 80 degrees right here. And then 80 plus 30 gives me 110, which tells me that this is 70 degrees. All right, doing law of sines here, I'm trying to find this value right here. I'm going to have that over that. So that'll be sine of 80 over x equals sine of 70 over 80. All right, cross multiplying there, I get x sine 70 equals 80 sine 80. Has kind of a nice ring to it, don't you think? So now I'm going to divide by sine of 70. Dividing by sine of 70. These cancel, and I'm left with x equals this. I do that in my calculator, and I get x is equal to 83.84. All right, let's return back to this picture, and I'm going to erase that x, and now I know that this is 83.84. I'm going to drop down this right here. That's what I'm looking for, my h. And now I am in really good shape. That's a 30, sorry about that. All right, so here's my triangle over here. I've got my 30, I've got my 83.84, and I've got my missing side, h. All right, solving that, I'm going to circle this. This is my opposite. This is my hypotenuse. So it's going to be sine of 30 is equal to my opposite, which is h, over 83.84. Multiply by that, 83.84 on both sides. And I get these cancel here, and an h is equal to 83.84 times sine of 30. Pick up my calculator. I know sine of 30 is a half, so I'm basically taking half of 83.4, or just plain do this in your calculator, and you get a height of 41.7 feet. All right, folks, that was real fun. Thanks for joining me.